Hello class, welcome to this video on the Chapter 9 review. So we're going to cover questions that are the first three lessons, which is of the chapter, which is on the equation of circles, classifying parallelograms, and coordinate proofs. So let's go ahead and get started. For the first one, we have a classification, sort of a proof of a specific type of classification, a parallelogram. We want to prove that the following figure is a parallelogram by definition. Now, the definition of a parallelogram, as you recall, is that you have two sets of parallel sides. So two pairs of parallel sides, and this is why it's referred to as a parallelogram. So let's first off, you're going to plot the coordinates. And connect your points to construct the quadrilateral, which is in this case a parallelogram. Now you might think, well, this is a rectangle. And well, we're not proving that this is a rectangle necessarily. We're just proving that it's a parallelogram. To prove that it's a parallelogram, remember, as we said earlier, by definition, it has to have two sets of parallel sides. To prove that this is a rectangle requires more specific. You need to show that these angles here are right angles, so that it has four right angles. We will not be proving that because we're not trying to prove that it's a rectangle, just that it's a parallelogram. So you're going to do your rise over run in order to determine if the opposite sides are parallel. So do that here and here, and you can see that those are the same number of spaces. This is going 2 up, 2 to the right. This is going 2 down, or 2 up rather. You always go left to right, so it's 2 to the right, 2 up. And then finally you have this one is going down 5 and over 5. And then this is going to the right 5 and down 5. And so let's go ahead and list out the coordinates here. It says PO. So we have coordinates PO. Okay, so it looks like the coordinates are PO and Y. So we're gonna, if we switch these, we have 5, negative 5. 1, 2, 3, 4, 5. 1, 2, 5. And so that should be the Y coordinate, that should be Y. And this one here, which is at 7, negative 3, should be listed as N. All right, so now let's go ahead and do the slopes. So the slope of PO is rise over run, so rise of 2, run of 2, which is 1. The slope of ON is, which is rise over run, negative 5 over 5, is negative 1. The slope of NY is going up 2 over 2, which is 1. And finally, the slope of PY is going down 5 and over 5, which is negative 1. So as you notice, the opposite sides here are the same slope, so they are parallel here, here, and the opposite slopes here. Opposite sides are parallel as well, same slope, and therefore we have shown that this is a parallelogram. For the next one, we have a figure represented by some coordinates, and we want to show that it's a rhombus by definition. Now remember the definition of a rhombus. You have to have the sides are congruent, okay? So in a rhombus is just a parallelogram where all of the sides are congruent. That's the definition here. So we need to prove that. So first we're going to construct the rhombus. All right. So we want to show that all the sides are congruent and of the same length. So we're going to use the distance formula to do this. So we're going to figure out the vertical change, the rise and the run. 1, 2, but not to calculate the slope, but this time to calculate the slope, the distance. So we got 3 up, 2 over. This one is 2 over, 3 down. This one is 2 up, 2 right, 3 up. This one is 3 down, 2 over. So the distance, and this is supposed to be the point E. So the distance for WA is the square root of the rise squared and the run squared. So we got 2 squared plus -3 squared, which is square root of 4 plus 9, which is 13. Now AV is the square root of 3 squared plus 2 squared, which is also square root of 13. VE is the square root of -3 squared plus 2 squared. And then finally we got WE, square root of 3 squared plus 2 squared. And you can see that these are all the same length. They're using the same numbers, and so they must be the same length. Therefore, this is a rhombus here. All right, let's look at the next one. So now we want to prove that the diagonals in the rhombus in this example are perpendicular. So we want to prove that this is a rhombus by showing that the diagonals are perpendicular. All right, so we're going to focus on the diagonals now. So we're going to draw this diagonal and this diagonal. So we're going to do the slope of each of those. So the slope, so let's calculate the slope of WV and the slope of EA. So the slope is for the WV, the green, is rise over run, and it rises 1, 2, 3, 4, 5, 6 units. So let's see here. 6, it rises 6 units. And it runs, rises 6 and it runs 0 units. All right, and then EA, we have it runs 1, 2, 3, 4, but it rises 0 because it's completely flat. So it rises 0, but it runs, I believe we said it was 4. So now let's go ahead and calculate the slopes and show that these are perpendicular. Well, because this 6 divided by 0, you cannot do 6 divided by 0. This is actually undefined. You can't calculate this. However, you can calculate 0 divided by 4. 0 divided by 4 is 0. The fact that the slope is 0 here means that the line is horizontal. And then the fact that this is undefined means that the line is vertical. A vertical and a horizontal line are always perpendicular. So if you have a vertical line here and a horizontal line here, they'll always be vertical. Or they'll always be perpendicular rather. So they'll cross at a 90-degree angle. All right, so if you calculate the slopes and you get undefined and 0, then that means that you have either a vertical or horizontal line, or both. And then if you have both, then they must be perpendicular. In addition, for this, if you were to flip 0 divided by 6, or 6 divided by 0, you would get 0 divided by 6, which is also equal to 0. So if you remember that if you do the reciprocal, and the result is an equivalent slope, as well as if you change the sign, so if I change the sign here to -0 divided by 6, I'm still going to get 0 because 0 is neither negative nor positive. So the negative is inconsequential. So following the definition of perpendicular slope, where you have the opposite reciprocal, also works here. Okay. So these are also opposite reciprocals, therefore they must be perpendicular, and therefore we have a rhombus. All right, so for number 4, we are focusing on determining the perimeter, not the area, just the perimeter of the trapezoid represented in the coordinate plane with vertices -4, -2, and so on. Let's go ahead and graph it first. We'll call that A, and depending on how the other ones are laid out, we'll label them accordingly. All right, so this is trapezoid ABCD. We're interested in doing the perimeter of the trapezoid. So the perimeter is the distance all around the outside. Okay, so let's go ahead and figure out the distances here. DC is pretty straightforward. It's 1, 2, 3, 4 units between. AB, also pretty straightforward. 1, 2, 3, 4, 5, 6, 7, 8 units across. Now from A to D, you have to do, since it's a diagonal, you have to do the vertical and the horizontal distances here. 7 up and 2 across. Here it's 2 across and 7 down. All right. So now let's go ahead and find the distances. We already know that DC is equal to 4, and we know that AB is equal to 8. So let's calculate AD. AD is the square root of the 7 squared plus 2 squared, which is the square root. This is 49, this is 4. 49 plus 4 is 53. And BC is the square root of 2 squared plus -7 squared, which is the same thing as what's above, because it doesn't matter if it's negative or positive, it's still going to add up to the same number as long as it's being squared. So these are the same. That means that this is an isosceles trapezoid. Not that we're concerned about classifying it, but if you were asked if this is an isosceles trapezoid or not, you would say yes, because these are congruent. The sides that are not parallel, that are congruent, are what make the trapezoid isosceles. Now, our perimeter is simply going to be the sum of all 4 here. So we have DC plus AB, plus then you have the AD, and finally your BC. Add the results together, kind of simplify things here. So we get P is the perimeter equals 12 plus, now you got 2 of these, so it's going to be 2 square roots of 53. Do not add these on the inside. So do not write this as square root of, and then 53 plus 53. That's not true. So that's not the same thing as that, okay? You just want to say, well, I have 1 of these, I have 1 of these, and therefore I have 2 of them. Just like if it was X, if I had that replaced with X, then that would be X plus X, which is 1X, 1X, or 2X, okay? All right, next one. Given the triangle with vertices F, G, and H, prove the midsegment theorem by completing parts A, B, and C. So the midsegment, the triangle midsegment theorem states that if you got a triangle, right? Any triangle, and you take 2 of the sides and you find the midpoints of those sides and you draw a line between those midpoints. That's referred to as a midsegment. If you did that, then the length of this midsegment is going to be exactly half the length of the third side that it's parallel to, okay? So it's going to be exactly half the length of this third side here. So if this third side were 10, then this midsegment will be 5, okay? So that's the triangle midsegment theorem. We're going to prove this little by little. So let's first construct the triangle in question. All right, so we want to make a quick correction. This coordinate here should be negative. So we're going to go ahead and make that into a negative, all right? And that's going to be our triangle, okay? So this is going to be G, this is H, and then, so the only issue that you got to correct is that that's a -8 for F, for the Y coordinate. All right, so now we have our triangle. We're going to go ahead and construct our triangle. All right, so now we're going to prove the triangle midsegment theorem by completing the following 3 parts, okay? Determine the coordinates of one midsegment by finding the midpoints of FG and GH. Okay, so we're going to do the midpoints of FG and GH, and then we'll connect them. So let's go ahead. We need to find out where that is, where the midpoint of that is, where the midpoint of that is, okay? We're not sure exactly where they are yet, so we need to find them. We'll call the midpoint, we'll call the point that is halfway here, we'll call it midpoint 1, and I'll call this one midpoint 2, and we'll calculate those, color coding them, of course. So we got midpoint 1. To find the midpoint, remember the formula for the midpoint is you average your x coordinates divided by 2. So you average your x coordinates, which means you add them up divided by 2, and you average your y coordinates, you add them up divided by 2. So let's do that for HG for the midpoint 1. The coordinates of H are -2 and 6. The coordinates of G are 10, 2. So you're going to add up the x coordinates for those. Doesn't matter what order. And let me color code that here. And we have the y coordinates you will add together as well. Divide that by 2. So we have here the midpoint 1, 10 minus 2 is 8, and 8 divided by 2 is 4. 2 plus 6 is 8, 8 divided by 2 is 4. So the midpoint is located exactly at 4 and 4. And that's pretty much where I was pointing at. That's funny enough, but and that's our midpoint. So now we'll need to do midpoint for FG, calling that midpoint 2. So do the coordinates of F and G. So add the x coordinates for F and G, -8 plus 10, then divide that by 2. Add the y coordinates, -8 plus 2, divided by 2. So the final midpoint here is 2 divided by 2 is 1. -6 divided by 2 is -3. So we have 1 and -3 right here. Okay, so we got our midpoints. Now we will connect them to get our mid-segment. So this here is our mid-segment in red. We want to show that that is parallel to this, right? So we want to show that because this mid-segment theorem only works when those are parallel. So let's go ahead. So this was part A. Now we want to show that it's parallel. We'll do that in part B. So we need to do the slopes for FH, and we'll call this AB, okay? So let's do the rise and run. This looks to be a rise of 14. This looks to be a run of 6. For the AB, looks to be a rise of 7 and a run of 3. So let's go ahead and calculate the slopes here. The slope of FH is 14 over 6. The slope of AB is 7 over 3. And these are equivalent fractions because all I have to do is divide by 2, and this converts to 7 over 3. So that means that these are parallel. So this means that FH is parallel to AB. Okay, so we've proven that so far. The final thing we want to prove is that the red line segment, the midsegment, is half the length of FH. So we're going to need to find the distance formula. So we're going to do the square root of 7 squared plus 3 squared. And that will give us AB. In fact, I will color code that because AB was red. And FH, we got square root of 14 squared plus 6 squared. And we'll go ahead and calculate these numbers. So we got 49 plus 9, so that's the square root of 58. We got 14 squared plus 16 squared. We'll go ahead and do that. 14 squared should be 196, but let's double check here. And then we'll add that to 36. We got 196 plus 36, so 232. All right, now we want to show that this is exactly half of that, okay? Is that true? Well, if you did the square root of 58 on the calculator, we'll do it here. We'll get 7.62-ish. And we'll now next do the square root of 232, which is 15 point, let's see here. Let's write this as 7.615. It'd be easier if we did that. And square root of 232 is 15.23. So if I double this, I should get 15.3. So 7.615 times 2 is exactly 15.23. So that means that AB is exactly half of FH. And that concludes my proof. So we have proven the triangle midsegment theorem. All right, so now that we proved this, let's go ahead and take a look at the next question. And this is true story here. I built a fence around this house, or around, my house currently. This past summer, I started putting up an 8-foot tall fence post before installing the boards. I wanted to know if the fence posts were placed so that they're perpendicular to each other. If fishing line or some kind of leveling line was connected to each post. I measured that the length of the shorter fishing line was 15 feet. The length of the longer fishing line was 20 feet. The length of the longest fishing line was 25 feet. Did I place the posts in the correct position to ensure a 90-degree angle at the corner post? Use all 3 measurements for the problem. So I want to show that this is perpendicular. So when you're building something, sometimes you need things to be a square corner, right? You need things to be at a right angle. And so I wanted to make sure, is this fence at a right angle, or is it going to look weird when I finish building it, right? So before I install the boards on there, the pallets, I need to make sure that this is the right angle or it's going to look funny, and I need to correct it accordingly. So I need to correct the position of the posts accordingly. So the length of the shorter line was 15, so this shorter side is 15 feet. The next longer, the longer one was 20, so this is 20 feet here between there and that post and that post. And then finally, for the longest, that was 25 feet. So we have here a triangle, and in order to determine whether that's a right angle or not, that's a question mark, we don't know yet. We need to use the converse of the Pythagorean theorem. All right, so we want to classify this triangle as either a right triangle or not. So in order to do that, you can use the converse of Pythagorean theorem, which is we got 15 squared plus 20 squared equals, remember the Pythagorean theorem was a squared plus b squared equals c squared, right? So if you show that this is true, then that means you have a right triangle. So a squared plus b squared equals c squared. C squared is always the longest, so it's going to be c squared will always be the longest, which is 25. Let's see if this is true. 15 squared is 225. 20 squared, 20 times 20 is 400. 25 times 25 is 625. If I add these together, will I get the third measurement, the 625? And the answer is yes, I will get the same measurement. And therefore, this implies that the triangle is right. So the triangle is a right triangle. And therefore, the corner here is indeed a 90-degree angle. All right, so I did place the posts correctly to ensure that they were at a 90-degree angle. All right, number 7. Now we're switching over to circles. Find the center and radius of the resulting circle, graph the circle. So we have here, graph the equation x minus 4 squared plus y plus 3 squared equals 64. Remember that the equation, the standard form of the equation of a circle, is x minus h squared plus y minus k squared equals r squared. All right, so hk gives you the center. So if the signs match, the answer is going to be positive. If the signs do not match, the answer is going to be negative. So our center here, which is given by hk, is h is 4, k is negative 3. Another way of looking at it is switch the signs in the equation. So if you see that this is a minus 4, well, then it's going to be a plus 4, right? In the center. And if this is a plus 3, well, it's going to be a minus 3 when you identify the center, okay? And then the radius squared is 64, which means that you need to take the square root to get the radius, okay? So the square root of 64 is 8. All right, so we got the center and radius. We should be able to graph it. So let's graph the center here. 1, 2, 3, 4. 1, 2, 3. That's our center. Let's do our radius 8 out from each side. 1, 2, 3, 4, 5, 6. We need some more space. 7, 8 right here. Right, then you go ahead and draw the circle the best you can. And there's my circle of radius 8. All right, now given the equation, this is the equation. This is an equation in general form, whereas the one before was an equation in standard form. In fact, this is not exactly in general form, so I'm going to put this in quotations because we had to clean it up to actually make it look like general form. So technically, this is not general form. We're going to actually convert it to actual general form. Okay, so in order to do that, the constants have to be on the right side, and the y's have to be grouped together on one side. The x's have to be grouped together on that same side. So I need to move this 10y over. So I'm going to subtract it over so that it groups together with this y. I'm going to add this over so that this cancels out and then move it over to this side. Okay. And then I'm going to leave this constant alone. Now, when I do that, I get x squared plus 6x plus y squared minus 10y equals negative 18. And this here is the general form. Okay. So now we want to convert this to standard form. So we're going to go ahead and do just that. Now this here is not a perfect square. So we're going to need to complete the square here. In addition, this is not a perfect square either. So we're going to have to complete the square. We'll show you this in the model. We'll do the area model and we'll show you the shortcut as well. So in order to model x squared plus 6x, remember that we have ourselves, in terms of algebra tiles, right? We have ourselves an x squared, and we have 6 of the rectangles, the 6 of the rectangular algebra tiles, which means you're going to have 3 on each side, right? So 3 here, 3 there, and also, and they're going to be positive, yeah? So, and then that means that you're going to have a total of a 3 by 3 in terms of the yellow squares. So, which is a total of 9. Okay, so this is going to be 9. And on the outside, this means that this is x plus 3 because you got 3 of these, and this is x plus 3 because you got 3 of those. All right, so let's draw the model for y squared minus 10y. So we have ourselves the blue tile, which is a y by y. And it says minus 10y. So instead of having the green rectangles, we're going to have the red side on the algebra tile. But we're still going to have 10 of them. So we're going to cut them 5 on each side. Okay, so you got those. And then that means that the number of yellow tiles you'll need, if you divided it, you get a 5 by 5 square, which is going to be 25. So to complete the square, we need to have 25 unit squares. All right, and that completes the square there. And remember that this is going to be y minus 1, 2, 3, 4, 5. And this is going to be y minus 5, okay? So we'll need that later. So now since we added 9 and 25 on one side, we need to do it on the other side. So we'll have to add it here as well. Okay, so on the right-hand side, if I add that, I get 34 minus 18, which is 16. Now I have to take this and convert it to a perfect square to something squared. Same thing here, to a binomial. I got to take this from a trinomial. Trinomial means 3 terms, to something that's a binomial, 2 terms, x plus or minus something. From a trinomial here to a binomial, y plus something, and therefore it's only 2. All right, so here I gotta figure out what this number is here and here. Well, use the area model. We have x plus 3 and x plus 3, and therefore it has to be x plus 3 squared. And here we got y minus 5, so it's y minus 5 squared. All right, the shortcut. I mentioned that there's a shortcut. Take that 6 divided by 2 and square it, and that gives you 9. You take that same number and divide it by 2, you get 3. Same thing here, negative 10 divided by 2 squared gives me 25. Take that same number, negative 10, and divide it by 2, and you'll get negative 5. Okay, so there's a shortcut for that. In any case, we have the standard form of a circle. This is now in standard form. So we can identify the HK. Remember what I mentioned earlier is that you switch the signs. If it's positive, it's negative for the H. If it's negative, it's positive. So it's going to be positive 5 for the K, negative 3 for the H. The radius is always going to be the square root of that number, which is going to be the square root of 16, which is 4. We can graph the circle now. We got negative 3, 5. And the radius is 4. All right, and we have ourselves our circle. All right, that's going to do it for the video, guys. Hope you found this useful and informative. I hope you took a few things, and as usual, I'll see you in the next one.